Hello and welcome. It is Excel World Cup Bootcamp Day 10. And in keeping with my recent trend, I'm going with just on time production. It is now 11:30 in New York. This video is due to be online at 12, so better get it done in one take. Today's topic is going to be scalability. And that's going to be a mix of a little bit of kind of technical tips and a little bit of tactical advice on how to think about approaching an esports problem. So what do I mean by scalability? Let's start with a simple example. Uh, Scalability, I mean two things. One is within every level of an esports case, you're going to have 10 or 20 or 30 uh, different sets of inputs that you need to run your thing on. So solving one level, if it takes you 5 minutes to solve a level, and then it takes you 5 minutes to solve the next one, and 5 minutes to solve the next one, you're going to be there all day. You'll never get it done. If it takes you 5 minutes to solve one level, and then in so doing, you immediately unlock the other 9 or the other 19 or whatever, then you're doing great and you're off to the races. So that's the first sense of scalability. And the second sense is scalability between levels, because it's often the case, it's not always the case, but it's very often the case that the levels build on each other. That essentially that there's like one or two big complicated problems, and then there's a series of steps sort of easing you into that. So like before you solve the big complicated problem, start with this simpler one and build up from there. So the first thing I want to talk about is scalability in the first sense, like scaling out to one level. And I want to sort of motivate this by showing you a couple of actual um, examples of sort of the alternative. So mostly we're going to be talking about data tables. Data tables are a great way to take a solution for one level and scale it, sorry, for one example and scale it to the whole thing. And more generally, they're a great tool for figuring out what would your model look like if you change certain inputs. But let's talk quickly about the alternatives. One alternative is each input is just one line. So if you can build your model in one line, then you can just copy it down whatever number of times you need, and that's no more calc intense than running a data table. Um, and sometimes, especially for the simpler levels, it's a great approach. But I want to show you a real life example. This is the case 500 by Tim Heng from the Excel World Championship semifinals, quarterfinals, I don't know, one of the finals rounds in 2022. I was knocked out by that stage, but I helped Andrew to test the case. And this is the actual file from my original test run. So I won't give you all the details of the game, but the key things you need to know is here's um, there are like 43 cards being dealt out to 4 different players and some put in a kitty. So I had like manually constructed this row that says, okay, this one goes to player one, first 3 go to player one, next 3 go to player two, and then so on. There's like a weird order that was described in the rules. So the first question was just how many spades does player 4 have in their 10 card hand? So I said, no problem. I'll just filter this where this is equal to 4, and then I can, whatever I did, count ifs on that for how many spades are there. Um, nice and simple. So then level 2 says, okay, oh yeah, so what would the players be willing to bid up to? So in this case, depending on the suit, there's a different amount that you'd be willing to bid up to. There's a whole complicated formula for calculating it. Again, for this example, you don't need to know what that is, but the point is you had to get, so here we're talking about player 3, you had to get that player's cards, then you had to score them for if the trump was a spade, you had to score them for if the trump was a club, score them for if the trump was a heart, and score them for if the trump was a diamond, and then put it all together to say, okay, so what's their maximum bid? So, you can see it's starting to get a little uglier now. We've got a model that's like 40, 50 columns wide, but not totally unmanageable. But so then I carry on to the next level, and the next level asks, what's the highest number of points any player is willing to bid up to? So now I have to kind of scale the original thing. I make one an input, have all of this, and then I do the same thing again for player 2, do the same thing again for player 3, the same thing again for player 4, and now it's starting to get pretty hairy because I'm getting all the way out to column HZ, HZ, depending on your preferences. And then it continues to get more complex after that, so I have this like huge mess, and I'm trying to sort of, mark off columns with an X and extract the relevant columns, and it's getting really ugly. So just to quickly show you the solution that I built, so that this was kind of what I built in the half hour. I was pretty confused by the case, and I was trying to kind of build as much as I could on the go. The solution that I built later looked something like this. Um, So I sort of look up the game number to get the list of cards, and then lay them out in a grid. Here's all of player one's cards, all of player two's cards, all of player three's cards, four cards, and then I could kind of size up. Okay, for each suit, this is whatever the points they get from big trumps, the points they get from small trumps, the point they get from non-trumps, and that gives me their maximum bid number, and their maximum bid points, and whatever other kind of weird stuff. So the good thing about this is you can now kind of see this all in one screen, rather than kind of one single line all the way across. So that's sort of the motivation for why you don't want to go horizontal. It works nicely for one or two early levels, but as the complexity grows, it can get very hairy. The other option, if you want to kind of avoid your model getting very, very wide, we talked about this. This is the what's my flight number case that I did the walkthrough of yesterday by Patrick Chatin. And we talked about how we had split this out, split the list of flights out into 10 columns, and then looked up each one of those into another 10 columns, and then summed those up. And in theory, you could just smash those all together into one big formula. So just put the text split as the first argument to the X lookup, and then wrap the whole thing in a sum. And again, on a level 2, on a moderately complicated problem, that basically works fine. This isn't great from an auditability perspective versus being able to see the data spread out, but once you get used to big formulas, it's no big deal. But again, if you try to solve a level 5 in a single formula like this, it's going to be very difficult. I mean, if you want the intellectual and the kind of programming challenge, then by all means give it a go. It's a great way to kind of hone your skills on advanced Excel functions, and go watch some of Excel Wizard YouTube channel videos. He does all kinds of crazy problems in single cell. It's very interesting. But in terms of what's accessible to people who are not Bo Ridabon level geniuses, and B, what's competitive to get done in 30 minutes, or to get done in your real life, just in a reasonable amount of time, that's not a great approach. So what we did yesterday, I just want to explain the mechanics of it a little bit more, was we made a data table. So again, I put the game number in here, so this started off as whatever, example 3. Look up the data for that case, and then I do all the workings here. I spread it out over multiple columns, do whatever I need to do, and then I get to the answer, which is this cell here. And then the data table lets me say, what would this answer be if I change this cell to each of these? And so we just kind of select the range, Alt-DT, or go to data. What if, not sheet, forecast sheet, sorry. As you can see, I'm not really used to using the ribbon for this stuff. I just Alt-DT. But anyway, what if analysis and data table. And then you tell it, I want to vary this cell, and I want you to tell me what would happen to this cell in all these different situations. So in other words, put 31 in cell A1. What do I get? And you can quickly kind of check. If you put 31 in here, this becomes a 75. If you put 46 in here, it becomes an 89, just like this. So this is just the equivalent of kind of manually typing in each of those numbers and saying what's going to become of each of those. While I'm on the subject of data tables, let me just briefly mention that data tables can expand. So this is just getting a single value. But if you wanted other values, like let's say you want to know how many Canadian flights are there, just as an example, then you could say sum of the Canadian flights, and then you can just select a wider range. So again, your input is varying down the column, so you can have as many columns here as you want, and it will, when I hit F9, recalculate all of those. So you can see, whatever, this is the game with the most flights to and from Canadian airports. These two are the ones with the least, whatever. It's the kind of thing you might have to answer in a bonus question. But just more generally, you can have as many formulas as you want along here, just laid out along one row, as many inputs as you want laid out down that way, and you can data table to calculate all of those. The other thing that you can do, I don't have a great example of how to use it here. Well, let's say you wanted to know how many flights come in and out of each airport in each case. So just grab all the airport codes. Sorry, that's the wrong level. Come over here. And sorry, go out into some space here. So I'll just paste those there. And then I'll take my list of game numbers and put them here. And I don't know. Again, here you could just do it as a single formula for one of these. But let's say there's something you want to see as you vary each of these two. So what you can do is a two-dimensional data table. So let's just say we say, I don't know, start off with YYZ and we'll say count ifs. How many arrival airports are YYZ? And in this case, the answer is 0. But so let's say we want to see what does that answer become as we vary both the game input number and the number of airports. So we'll just do this, Alt-DT. So again, the column input cell is what's going to vary down the column, so that's the game number, which is in A1, and the row input cell is what's going to vary across the row, so that's this airport code here. And refresh, and it'll take a little longer to refresh because that's just running it more ways. But then you can see, so if you wanted to know something like how many flight schedules have more arrivals in Sydney than in Bogota or whatever, you can do that. Again, it's the kind of question that sometimes comes up in the bonuses. Now, this one would actually be more efficient to just have one formula for each airport code laid out along here, and then just run that 20 times. Because right now what's happening is the model is recalculating 240 times, like 12 airports times 20 of these. And so if you can just calculate those 12 separate things and make those 12 separate inputs to one data table, then it just recalculates the whole model 20 times. So from an efficiency perspective, you only do this if, basically, if this drives a bunch of other things that change the model in a way that you can't just get out the 12 different answers in parallel. So that's data tables. Then, oh yeah, the other thing that I wanted to talk about just as a sort of principle a little bit is the idea of sort of building up the complexity. So like, for example, when I went from level 3 to level 4 on this question yesterday, I copied my level 3 tab, cut out some stuff that was no longer relevant, but kept as much as I could from there. This case isn't a super one for kind of building up like that, but let me show you one where this made a very big difference. And this is the backgammon case from one of the qualifier rounds for the Excel World Cup this year. This was a very, very difficult and complicated case, including the very intimidating wall of text here. And I think the median score on this case was about 200 out of a possible 1,250. With a big part of the challenge being that just getting started was not easy, because level 1 was pretty straightforward standalone, but level 2 was already quite complicated. So again, I don't need to teach you all the rules of backgammon, but basically you had various kind of white pieces here. You had dice that are rolled to determine how they move, and they're all trying to get down to this goal here. So you roll a couple of sixes, then you can move two of these pieces off, and there's various other rules for kind of in between steps. But the interesting thing to mention here is there was a lot of complexity in getting going with level 2. But if you read ahead, you look at, okay, so level 2 is that. Level 3 is basically the same thing, except that now there's two players. There's a black player trying to get off this end, and there's a white player trying to get off this end. But 90% of the mechanics are the same. Then level 4 is the same thing again, except now the dice can contain doubles. So the idea is that if you, I guess this is real backgammon rules, I don't actually know, but if you roll a double, then you get to use that number 4 times instead of just 2. So if you roll a 5 and a 1, you get to move something 5 spaces and move something 1 space. If you roll 2 5s, you get to move 4 things 5 spaces. And so the 90% of the workings, like I said, for levels 2, 3, and 4, and actually 5 as well, were the same. And so what actually helped me a lot on this level was I read levels 2, 3, and 4 and decided, okay, I'm going to try to build a model that will basically work for all of these levels. Now, when you think about tactics like this, especially within the half hour time constraint, like if you have unlimited time, it's great to just design a nice general solution. Like if you're doing this in the real world, in work, whatever, just take the time before you do any banging on keyboards, design a nice general solution, and then build that. And the time taken to do that will be way less than building one thing and then bolting on another thing and bolting on another thing, and so on and so forth. But in the competition, whether this is a good idea or not depends a lot on your sense of what you're able to get done in a certain amount of time. And that's one of the biggest tactical elements of this game, is how well do you understand what steps are going to be involved here and how quickly you can do them. And you'll only get that with experience. The reason I mention this is because I ended up winning this round by a pretty wide margin. I got like levels 2, 3, and 4 out, and got something like 800 points. And I think the second place person got low 400s. But I got to about 27 out of the 30 minutes, and I'd done the sort of standalone level 1, but I had no points yet from levels 2, 3, or 4. And then, I got it finished, and the setup I had built worked for levels 2, 3, and 4, and I got them all out pretty quickly. Um, but that's something to be aware of. So there is a risk in doing this. But let me show you a simple example. When I built this, there's two. You split this out. I get 2 dice per player, and so I turned that into, okay, so this is a 5 and a 6. You got to use them in descending order. So here we go. We turn it into 6 and 5. Don't worry too much about the details of the formula. The only thing to emphasize here is what this formula is saying is if this is checking for if the 2 dice are the same. If there's a repeated dice, then it's saying stack the sets of dice twice, so that when you get to level 4, that same formula is outputting 4 columns. But on level 2, it's only outputting 2 columns. And then I set it up with a 2 call, the way we talked about flattening data before, to flatten that into a column. But I flattened across all 4 columns. So even though I wasn't using 4 columns in level 2 or in level 3, because I set it up with 4 columns, then as soon as I get to level 4, I didn't actually have to change anything. I just had this formula that already kind of stacked them next to each other. But even if you didn't have this formula set up, if you just had a formula that said, give me the numbers for these 2 dice, as long as you sort of have this referencing the 4 columns, then you can come along later and add something that's going to expand that. So that's something to think about in terms of scalability. Not just kind of building it all in one go, but can you put in like a placeholder? As in, can you say, okay, I haven't actually worked out these 2 columns yet for when there are repeated dice, but if I do it later, it's just going to look like 2 more columns here and then flatten the whole thing out. So let's do that. Compared to if you built level 2 in a way that said, okay, each pair of dice is 1 row, so I'll do kind of, one step in one block of calculation and the next step in another block of calculation, then you kind of need to restructure your model to deal with having 4 dice. So I honestly don't know how clearly that came across, but I hope you get the idea. The other thing, just for fun, is that sometimes it's easier to sort of solve the general case than to solve specifics. So this is, again, an example from the Battle of 16, which was sort of the very first of these knockout tournaments, way before the XL World Cup was a thing, back in 2021, I think. And this was one of the quarterfinals cases from that, which was you're playing bingo. So 2 players have 2 bingo cards. The numbers get drawn. So for each game, the numbers get drawn in a certain order. So in game 1, it goes 15, then 37, then 21, and so on. And you mark off your numbers as they come up. And depending on the game, you have to complete a certain shape. So in one game, you have to complete an L. In another game, you have to complete a railroad, and so on. And so for each level, it showed you, the pattern is an L, the pattern is a railroad, the pattern is an H, and so on. And you had to solve each one of those. So it's quite tempting with something like that to say, okay, well, an L is a relatively simple pattern, so I can just get, this column of numbers and this row of numbers and work something out with that. Railroad is pretty simple, I can work something out with that. But if you look at it instead and say, okay, I have an input that is a set of ones, and I've actually kind of cleaned this up. The original input was just color, but I've turned it into kind of ones in all the cells where you'd have a number. If you just think of that as an input, and these, again, there were lots of merged cells here, so you had to kind of tidy this up to actually be a 5 by 5 rather than a 10 by 10. So I've done some of that kind of pre-cleaning. But if you think of it as, okay, so the L as an input gives me this grid, or the railroad as input gives me this grid, and then kind of just work with the grid to say, okay, when is the last one of the things that is a 1 here going to hit, then you can solve the whole thing in one go. So let me just briefly show you what would that look like. So this is a case where you need an offset to do this lookup. So what I want is to take one of these names as an argument and return this. So I'm going to say offset from this first one by how many columns, sorry, that's rows, second column to make it how many columns, X match this pattern against the list of patterns over here, lock, and then subtract 1. So if I have an L, it gives me that. If I have an H, it gives me that. If I have an XL, it gives me that. So what are we saying here? We're just saying shift over a certain number of columns according to how far you need to look to find this thing. So in other words, if you match railroad, it'll match on the, whatever that is, some of those up, 7th column. So then you shift this over by 6 columns, 7 minus 1, and it'll land there. And then you can say something like, if that is equal to 1, then refer to the range here, which I think I gave the name p1num, p1nums, otherwise let's just say blank, and that gives you, these are the numbers that you need to complete the L, and then you can just match each of those. Again, I'm kind of building a single giant hairy complicated formula here, which is not good practice, but I just want to kind of quickly show you the idea. So you match that against that, and it gives you a whole series of numbers and some errors. So then we'll just say if error this 0, and you want to know when the set is complete, so you just need to know the largest of these numbers. And that gives you player 1's final position, and then you can do the exact same thing with, just change this to a p2nums, player 2's final position. So then you take I think the question was what number is drawn when somebody wins the game. So the first one to complete wins the game, and then you can just go back to here, index, whatever, all the way over to C38 to, I have to do this manually because again there's lots of merged cells here, so it's 2 rows which index won't like, out to EU38, and index that by this smaller of the 2, and that gives me a 70, and then you can copy that down and fill in all the levels in one go. So again, just an example of the sort of thought process involved. If you think about scalability, think about building one level in a way that will set you up to solve another level, or think about all of the levels as special cases of some general principle and solve that general principle. Again, it comes with the caveat that if you spend 35 minutes building a beautiful general solution that then answers all the questions, then you get 0 points. So it does require a bit of experience, a bit of knowledge of how far can you get in the time. But once you start to get to the point where you'll be able to solve kind of more than one level or more than 2 levels or whatever, then it's definitely worth thinking about, should I do an approach that's going to cover a few of these in one go. Anyway, I've gone on much longer than usual today, so I'm going to leave it at that. Thanks for watching. We're going to have, this sort of marks the end of our 2 big chunks of text week and lookup week. So the rest of the time is going to be a mix of kind of small tactics, tricks, maybe some input from some other friends who do this stuff, and then a little bit of just what to expect on the day ahead of Thursday, which is game day, first game of the season. So that's what I got for today. Thanks for watching. See you next time.